Right, so in UCS, what all we are going to look at is about the Cisco UCS blade chassis, the blade chassis. Now, CHASSI chassis and then rack mount servers. Now here I want to make one thing clear, that the C series servers are called as rack mount servers, C series, and B series are blade server. So whenever people say B series, they mean blade server. Whenever they say C series, they say rack mount server. So we'll see much the difference between these things, and then we'll also discuss about the fabric interconnect. We already had an introduction to this, but again we'll go much more deeper into it. And again we got the IO module on the chassis. IO module on the chassis. Is the spelling right? Yeah, it's right. So IO module on the chassis. There are different module available. Some are 4 ports, some are 8 ports. So we'll discuss about those things. And this IO module is the one which you see behind the UCS chassis. On the front side of the UCS box, we install the servers. On the back side, you can see some ports which is connecting to FI. So those ports that is behind the chassis that connects to the FI, fabric interconnect, we call it as IO module. We'll have some ports here and some ports sometime in the middle or sometime here, and these are connected to FI box. So this one we call it as IO module, and this is fabric interconnect. Now this IO module is of different series of IO modules. We have different speed. Those things we are going to deal with much more detail today. And then we'll discuss about virtual interface card, VIC, virtual interface card, and converged network adapter. Virtual interface card, what it is, converged network adapter, what it is. This virtual interface card, sometimes it is also called as Palo card. Palo card, and some says that it is the word Palo because of a location in US, but I also saw a meaning for Palo in which is coming from a Spanish language. Whatever, some people call this virtual interface card as Palo card. Palo card is nothing but VIC, virtual interface card. And then UCS blades itself, we have half blade, full blade, half blades, full blades. And then UCS manager, that is the FI where the manager is. We have two different mode, two different ways in which you can manage, one through GUI, another through CLI. We do the initial configuration using CLI, and then we switch to GUI once the basic IP address is in place. So when you have IP address configured through CLI, we can do HTTPS from the web browser and get the GUI of the UCS manager. 90%, we can say 99% configuration is done through GUI, except that initial configuration. And also we will have a recap of Nexus 1000V. So these are all the entire, the plan of study in our UCS. This is not for only today. This is the plan for the entire UCS training. So about this C series and B series, blade series, we will discuss in detail in the next class. And today our focus will be more on IO modules, FI, UCS blades, and so on. And also when we have rack, we will be doing a lab called the boot from SAN. Boot from SAN, which this will be the best, the final lab we can say. Instead of we having the operating system locally, we will have in a storage device in remote in a network. We will boot our machine servers by using that storage area network. So that's the final lab that we will be doing. I'll be sharing a very nice lab book in the next class for complete UCS, one lab book which will teach complete UCS step by step. I'll also follow the same thing, and I'll give you the same.
Sir, that
Yes,
book, lab book will be like INE book?
No, it's not an INE book. It is different. It is, I think, Cisco Press. It'll be like step by step, like creating vSAN or VLAN or creating profile. Step by step, learning. It's very difficult to learn UCS, GUI of UCS if you don't have a step-by-step approach, systematic approach. So that step-by-step approach is what's taught in that book.
Thank you.
It is from Cisco. Not too many pages, limited, but it's really very nice. I have in my another mission. Otherwise, I'll just open and show you immediately. But I don't have that in this mission.
Okay. So you can, if you don't mind, can you please send?
Yeah, soon
later
after
on?
this class.
Okay,
Soon
sir,
after
alright.
this class.
Thanks, sir.
Welcome, sir. All right. So Cisco's manager. So one of the advantages in Cisco UCS manager is it is developed by using a open XML application. It's an open source code where anyone can take and develop or manipulate, as we have Red Hat developed based on the I forgot the language name, based on the open source Linux, as the Red Hat is developed, or SUSE, or there are a lot of Linux versions. I forgot. SUSE, Red Hat. So all those, they have a common kernel, common base. Common base API. So same like that, which is an open standard. Same like that in UCS also we have a open standard XML application, or by using which this UCS is developed, and even we also can manipulate by using this. So that's one advantage. And another advantage is its lack of intelligence or switching. at the chassis level. Means there is no much switching job or at the chassis level. Meaning the chassis is not an intelligent box. It is the FI. It's the manager. It's the UCS manager. So if something you want to change a server, you just swap it. You just swap the server. You take the old server and you put the new server. It will be recognized, and all the policies that were there before for that old server will be added to this new server in no time. So that's an advantage actually. Lack of knowledge at the chassis level. Lack of knowledge. So the chassis has no intellectual. It's been controlled by FI. All right. It's same like for 1000V we learned that if I change VM from one location to another location, it's not going to really matter. Or if I want to change a VM, corrupted VM, it won't take much time because it's a small file I need to copy instead of the old file. So same like that here also. We have we have that profile, port profile. Here we have a similar kind of approach, port profile approach, which has been centralized, managed by the UCS manager itself, not by the chassis or not by the switch or not by the server. And then here we have a tagging mechanism called VN tag. VN tag, which goes from servers are there, blade servers are there in the chassis, and the servers are connected inside to a virtual switch or physical, whatever the switch is inside, which has got a lot of ports, and servers are connected to this. And this is the IO module we call, and this IO module have limited number of port, maybe 1 or 2 or 3 or 4 ports. This port is what connected to the FI box, Fabric Interconnect A, the primary one. Likewise, the other will be connected to the Fabric Interconnect B, the subordinate one. So to identify the traffic that is coming out of the server till this level, we have a special tag called VN tags. So we will definitely go deep into this thing. And then, as you already know, we also have an emulator in which you can do all that you do in a real manager, UCS manager. You can do here also. You can do 99% of what you do on the real UCS manager. You can do with this emulator that we already installed in our VM machine last class. So only the thing that you cannot do is you cannot connect to a Nexus 5K or something and find out and verify the output. But the configuration, implementation, everything can be emulated. You can add servers and observe what happens. You can reduce some memory, increase memories. Those things, you can create a port profile. You can create SAN, VLAN for SAN, VLAN for LAN. All those things we can create. You can create port channel. See, if I want to do port channeling, I can do port channeling here, which is not default. You see, if the port channels are there by default when it goes from server to this switch IO module, the port channels are by default. You no need to create port channel. Those port channels will get created automatically. But between the IO module to the Fabric Interconnect, port channels we need to create. If you want to create, you can create that, and those things can be emulated very well. And this lab that we were talking about, boot from SAN, those things we cannot really practice. So, but the configuration for that we can do, but we cannot see the output. So 99% of what you do with the real device you can do, but only the outputs cannot be seen as you see in the real device. So about the physical architecture of the UCS we know. Yes, sir.
Sir, so we have our Saturday lab, like
Not this
Saturday after
coming.
two
Not
Saturdays, right?
Yeah, not this Saturday. The following Saturday.
Okay. Sir, so these many topics that you just told us, and it is good to learn now. I mean, and they are very good, right? But there are too many. I mean,
No, no,
so
no. It is
it
not
is
too many.
all of them need to know for exam.
No, no. For exam, sir, exam. I'll give you the video, exact video. You just see that video and go and click and come. That's all. Very less number of steps,
Okay, sir.
and UCS will be already configured. You need to go and verify whether it is properly configured. Definitely, they have done a lot of mistake there. You need to go and change those mistakes. That's all. Sometimes unwanted ports are being allocated as fabric. You need to go and change that. Some are unnecessarily made as network type, where you may not need a network type. So you need to cancel those network types. Some interface need to be changed from Ethernet to network type. You need to go and change it. So those things I'll very clearly show you in the video where to change, and
Okay, sir. Okay, sir, I
then
got it.
that's all.
So
Okay,
that
exam is
means
not a matter.
yes, sir. Okay.
So
Okay.
if
Got it.
otherwise, I won't be really going through this theory. This is a theory class. I
No,
can
no, no.
very,
But I need to. I like these things because
yeah,
otherwise exam is not a. I think
yeah.
big
See,
target.
correct. Exam is also a byproduct. It should be a byproduct. When we learn this, that should happen automatically, easily.
Yes.
So this one, I have seen people straight away. UCS means they will say, "Hey, graphical user interface. Click this, create VLAN. Click this, create a SAN VLAN. Click this and do this. Click that and do that." That no need to teach me actually. I can do that. No one taught us to use Windows machine. We learned that by ourselves. Same story. Anyone can learn UCS by themselves if they have little bit English knowledge and a little bit network knowledge. So first of all, let us understand in what way UCS is better, how it works. If you see, you will understand today itself. You will understand that all the VPCs that we learned, everything is there inside UCS box. The fabric path we learned, VPC that we learned, everything is there inbuilt. So for the servers to connect, you will really see the top of rack approach here is it's really amazing. So let us go through that and try understanding better what UCS is. UCS is going to take different form, different dimension in coming days. That's why there are many trainings conducted nowadays on UCS in many companies. So physical architecture of UCS, we got what FI, Fabric Interconnect. So Fabric Interconnect is the core of UCS platform. It's the core. It's the core for UCS, core of UCS. Unified System, Unified Computing Server. Unified Computing Systems. So everything we have at last connects to where? It connects to FI. So I can say everything. To Fabric Interconnects. And then Fabric Interconnects is the one which is running the UCS manager. So where do we get manager? We get UCS manager on the Fabric Interconnect. So this is what we need to know about Fabric Interconnect. It's a core of UCS, and all the servers that is there on the chassis are connected internally to a IO module, and IO module is connected to Fabric Interconnect. So there are some FI that supports up to 20 chassis. We can connect 20 chassis to one Fabric Interconnect. There are some FI that can even connect to 40 chassis. But we need to be very careful about the oversubscription. So that is what. So we can have chassis from 20 to 40. But in real world, I don't think we will be using that much because of oversubscription. And there won't be also a need for that. So 20 chassis, you know about chassis. Each chassis can have half 8 blades, 8 servers. Inside that half 8 blades, you may have some VMs again. Each blade may have 3-4 VM machines running. Then if I have 4 VMs on each half blade, then 8 4s are 32. 32 machines, 32 computers are connected to one port of FI, one single port of FI. Now those things will be sometime oversubscription. Anyway, to have a common understanding about how many can be connected, this is what 20 chassis can be connected. Sometimes some Fabric Interconnect they do even support up to 40. I would like to give you here itself which one supports 20 and which one supports 40. I'm sorry, I didn't make a note. I read somewhere. Okay, I'll give you a very clear picture of which one supports 20 chassis, how it can support 40 chassis when we have redundant FIs with add-on cards on it. They can even go up to 40. That's the method it comes actually. All right. So this is the first physical component that we see. One is FI, Fabric Interconnect, which is a core which has got the manager to which every servers are connected from this chassis. So the next component that we see is chassis itself. So we saw the top one, the top 2 box is over, and below is coming a very big box called chassis. So chassis consists of blades. They contain blades, but those blades are dumb if they don't have Fabric Interconnect. They don't have any special, they don't have intellectual. They're not intelligent box. They are dumb box. They are slaves, we can say. They are slaves to FI. No intelligent. But what they got is they got whatever the computer will have. The computer will have CPU, RAM. Likewise, this one also has got the blade. Each blade has got its own central processing unit, or a RAM, random access memory, and they also got a network adapter, but here we call it a CNA, converged network adapter. Why? It needs to talk to SAN and LAN, so converged network adapter we got. So each blade has got its own processor, its own RAM, and its own converged network adapter, CNA. So this will be controlled by FI. So FI is the operator. So the next component that we have in UCS is IO module. As we already discussed, that IO modules are seen at the rear side of the chassis. This is a removable component actually. IO module is also one which can be slided. So it slides into the chassis itself, into the back of the chassis. Now what it does is it do the multiplexing job. IO module, it does multiplexing job. What I mean when I say multiplexing, we have multiple servers, and we got the IO module, and this IO module has got 32 ports inside connected to the back panel of the motherboard. And the uplink ports, you may have 4 or 2 to connect to the fabric interconnect box. So it's connected like this. So this is what multiplexing, you see, very less number of input, or here more number of output, or if you say many number of input, very less number of output. So multiplexing is happening here. So IO module slides into the chassis. This IO module multiplex the data from FI to the blade. IO module multiplex the data from fabric interconnects to the blade. So that's what we have in IO. Now in case if there are few series of IO module, I'm just writing the one which is popular. If I have 2208 XP IO module, it has got 8 uplink ports, 8 uplinks that connects to the that can be used to connect to FI, and then it has got 32 server facing port. 32 ports facing server. So this is what I drawn here. 32 server facing port. I'm circling it here, green one, and it has got 8 uplink. 8 uplink. So that's what 2208 XP IO module has got. Like this, we have different varieties of IO modules that you can see in the same page which I showed in the previous class. When you go to Cisco website, I'll quickly show once and then. B series is what we are seeing. In B series, when we go here, 5100, you can get a nice 3D module where we can see all those IO modules. I don't upgrade that Java. The reason is UCS. Emulator will have a problem if I upgrade. Okay, here we go. The one which we saw is UCS 2208. See, this is what we saw just now, which has got 32 server facing ports. It is behind. So this is this one. I want to rotate it. So here we got what, 8 number of uplinks. This 8 number of uplinks are connected to FI, and this is just an interface. That's all, the middleman between the server and the FI. And this is the one which gives us 32 server facing port. This is the one. This is not looking like a NIC card. Why it needs to be a NIC card when you are going to mount the blade servers into the chassis? So they are like this. This is what it gives you, 32 ports, but not as a NIC card, but whichever suits the need, to talk to the server. Let's see, 6120. Okay, well, before that, let me go back to this and let's see what it is. Okay, I'll take the other series. Okay, 6120 talks about the extension module, not the IO port. It's an extension module on the FI itself, this port. So what we saw is we have two L1 and L2, L1 and L2 on both the fabric switches, and they're each of 1 Gbps. L1 must always connect to L1, L2 must always connect to L2. This is for synchronization, because you got this one and this one. What is that? Each blade server has got at least 2 ports internally. So one will be connected to one IO port, another will be connected to another IO port. If I have 4, then 2 will be connected to one IO port, another 2 will be connected to another IO port. So because this cross has been happening inside here itself, we need not to do cross connection when we connect between IO module to the fabric interconnect. Just IO module A, you connect to fabric A. IO module B, you connect to fabric interconnect B. So these IO modules have got something called CMS. Chassis Management Switch. Now this CMS job is to communicate to CMC. Now the CMC is also there on that same IO module, CMC. CMC stands for Chassis Management Controller. So Chassis Management Switch has got hold of Chassis Management Controller. CSM, where do we see? And again I am writing CSM. CMS. We see this one on the IO module. And this controls CMC, Chassis Management Controller. Chassis Management Controller, Chassis Management Switch. So Chassis Management Switch is there on every blade server. chassis management switch. Chassis management, I'm very sorry, I'm confusing you. Chassis management controller is there on every switch. Chassis management controller is there on every switch. Now the job of this is to monitor all the sensors and monitor the voltage, monitor the fan speed. So that's the main job of CMC. Now this CMC is there on every server and communicating to this CMC, which is under the control of CMS, chassis management switch. And the CMS has got communication tie-up with FI. So the job of CMS, the chassis management switch, it's the one which manages the traffic to and fro from the FI to the UCS. It is the job of CMS, chassis management server job, is to manage the traffic between FI and the chassis, or FI and the IO module. FI and the IO module. And the job of CMC, which is there on IO module as well as the server, is to monitor the sensor monitoring. What sort of sensor? Voltage sensor, fan speed. And so on each server. The voltage that comes to the server is being controlled by this, managed by this, the cooling effect. All these things are taken care by this CMC. And it is also used to discover the chassis blades and the IO module. So CMC is also responsible for helping IO module to discover the server. The servers, when we insert, it's a hot swappable, you know that. When we insert a server, when we insert the blade, it is the job of CMC to give attendance to the IO module. Hey, I'm here. I'm so and so. This is my speed. So all those things are given by the sensor to the IO module. That's the job of CMC. So this CMCs talk to the CMC on the IO module. Alright, we were also talking about the fabric extender sometime before here. Now in the fabric extender we got a special series which is there in exam called 6248. The 6248 has got 32 ports. It has got 32 ports by default, but we can extend up to 48. How? By adding the ports on the expansion slot. So 6248, I would like to, do we have 6248 here? 6248, we got 61, okay, 6248 expansion module. So this supports up to 16 expansion slot. Okay, go behind. Look at this, it has got 16 now. The previous version which we saw got only 8, but this has got 16 in it. 1, 2, 3, 4, 8 on top and 8 on bottom. So if you don't have the expansion slot, all that we got is only 32 ports. We can extend up to 48. How? By adding the module 6248 module. The module name is 6248. It is not the IO module, it is the module, the expansion module that we add 6248. That's what I did. 6248, insert it back. So this is a special module. Why I'm saying this is the one which has got the maximum. No expansion slot is more than 16. You can see the other module which we already saw, which has got only 8. The maximum is 8. It can have 6 also, it can have 4 also. So it has got only 8. It can be 6 or 8 or 4 with various speed and feature in it, fabric support and so on. And it is said that now itself I want to add, but it will also come in some other class. In 6120 you got 4 ports dedicated for FC fiber channel. 4 port, this green one, this 4 is dedicated for fiber channel, whereas in the version which we saw, where it is 6248, all can support both FC as well as Ethernet unified. So this all can support. Okay, they don't have any explanation here, but I remember I read that this ports, any port can be used for FC as well as Ethernet. Just the mode change we need to do. Alright, there is another module called 6296. I don't know whether we have that 6296. Now, one thing I want to say here so that you can remember. See, this is what we saw, 6248. What is the maximum port you get? 48. 6248 means, maximum you can go up to 48. By default it is 32. So the next module that I am talking is 6296, which means up to 96 I can have, along with the expansion module. So this talks about 6296, then it talks about FI itself, 6296. It's not in the list. The Java that I have is blocking. 60 to 48 here also we see. Okay, this is the one which we already saw. Let me check for. Oh, here we go, 60 to 96 UP. Let me see how it looks. Is it talking about the entire switch or IO module? Sorry, the module, expansion module. Oh, it's a bigger one. I thought 16 is the maximum, but here it is written 96. Okay, it's a fabric interconnect itself. It's not an expansion slot, it's a fabric interconnect itself. Cisco UCS 6296 hub fabric interconnect is 2 rack unit, 10 gigabit Ethernet, FCOE and native FC switch offering up to 1920 Gbps throughput. My God. Okay. Okay, here we go. The 96 port. Unified 16 port expansion module. 48 port. 10 Gbps. Okay. Throughput and up to 96 port. The switch has 48 port of 10 Gbps. So FC and native FC. Unified port 16 unified ports. Yes, sir. You want to say something?
Yes, sir. So these ports will be connect to this below this ports, right?
Yeah,
on
below. Like this, you can have many chassis. Now this can support more number of chassis. See the throughput it has, 1920.
Yes, sir.
You can really have 40 chassis also, no problem if you have 40 chassis. If each chassis is giving you, let's say, if I have 8 server and 8 server, each server needs 5 GB, let's assume 5G, 8 5s are 40. So one chassis needs 40 GB. So 40 chassis needs 1600 GB. Yeah, this is okay, 1920. We can have 40 chassis with this.
Sir, can you please tell me again? But how did you calculate?
Okay,
How much?
I was doing some assumption work. Don't take it like that. Now one chassis has got 8 servers, right? Half blade. Correct. If it is
Yes, sir.
half blade, we have 8. My assumption is if each blade needs 5 Gbps throughput, 8 fives in one chassis I need 40 GB throughput. Correct, sir?
Yes, sir.
Can I say that? Am I
Yes,
making
sir.
any mistake anywhere?
No. I'm okay.
Okay. Then if I have 40 chassis, then it is 40 into 40, right?
Sir, if you can show me one chassis means what, like in the diagram,
One chassis means this is one chassis.
whole block,
Yeah, the
like,
entire block. This entire block is one chassis.
and we can take it out. Move it
Yes,
out or not?
this is separate. This is separate. This unit is separate.
But inside one chassis we have how many servers? Let's say 8 or
See,
5, right?
you have one here, 2, 3, 4. This is one full blade, and this is another full blade. In this, I have totally 4, 5, 6 blades. 2 full blade and 4 half blade. You want
And
me to
each
take
blade
and I'll take
move
and
out?
sorry, sir. Yeah, you can move it out. I'll take and show you. See, this is third version of server, half blade. I'm removing it. Sorry, full blade. It's a full blade. It's a full blade. This is removed from the chassis. B420 M3 blade server. It's a full blade with a Xeon processor in it. UCS Blade server advantage 4 socket computing with the cost effective. Let's see what this one says. I want this one. Mezzanine connector. We will talk about this mezzanine connector in some time. It's a connector which it has inside. See the VIC, virtual interface card. Sometime before we saw in the beginning of our class, which connects to the motherboard. We'll discuss what is this 3 mezzanine connector means.
Yes, sir.
So now let me show you M2 version. What you saw is M3 version, which is a full blade. Okay, this is also full blade but older version. Okay, this has got 2 dual port mezzanine card. Then if I have 2 cards, then I got 4 mezzanine ports. Mezzanine. Okay. I would like to show you now half blade. Okay, 230M. I don't remember these numbers, which is full and which is half. Definitely this should be half. 230. Yeah, here comes the half blade. This will have mostly 2 mezzanine ports. How many ports it has got? Nothing is written about the ports. Okay, now in the place of, put it back, in the place of one full blade, we can insert 2 blades. So if I don't want this 2 blade, if I don't want this one single blade, if I want to keep it as 2 separate servers, I can have it. I can take this one out. In this one place, I can put 2 servers, half blade servers. So if I have half blade, I'll have 8. If I have full blade, in one chassis you can have only 4 servers. If you have full blade, you can have only 4 servers. If you have half blades, you can have 8 in the same chassis. You can take these out and put 8 half blade.
Okay. So you said one chassis, let's say, and each server needs 5 GB bandwidth. That means 40 GB for one chassis, right?
Chassis. So if we talk about 40 chassis connecting to the connecting to this one, because it has got how many ports? 96 ports. It is 60 to 96.
Fabric FI, right?
Yeah, this FI is 60 to 96. It has got up to 96 port. So if I connect 40 chassis to that, so 40 into 40 is 1600 Gbps throughput. Correct, sir?
Yes, sir.
So what it supports maximum? It supports more than that. It supports, see, it is written in the second line, 1920 Gbps throughput.
But sir, where are we going to put all 40 chassis? Like?
Very good. This is the port. Sir, it will be connected.
Where are like separate in separate racks or one on top of each other, like 4?
On top of each other. I'll show you here. There is one one picture I showed in the previous class also, but I'm going to show you once again. Maybe in the other version I saw. It is recommended to keep as you're going to see in this picture. If you want to keep in different design, that's up to our wish. But let me show you how it is recommended. You just keep one above the other, and then on top you keep FI. That's how it will come. I'll show you.
But that will be huge.
Very, very, very huge heap of mountain.
Yes, sir.
Then in the breadth-wise you go bigger. Breadth-wise you keep more, height-wise it will be reduced. Okay, here, okay, UCS scalability. It shows how it can be scaled, how many servers it can connect, all the stuff. And this has got just 40 ports. See how it is kept.
Oh boy. Now I got it. It is it.
Okay, this is chassis, separate chassis. All are connected to this FI on top.
Okay.
One,
So
two,
it is
three, four,
not easy to no, but it is easy actually.
10.
This one is separate, right? So
Yeah. So now you got 40 chassis here in the diagram, in the
not
picture.
very expensive.
Very, very expensive, sir. Crores of money.
Yeah.
All right. So, and we already discussed there is no need of cross connection between FI or FAXB and so on. Next thing, okay. Now, I'd like to pick one picture from Google. I'll just try whether I'm getting some image as I'm expecting. This is UCS, right? UCS image. This picture is nice, but not enough. This is also nice, but not now, later. UCS. VIC, Virtual Interface Card, 1280. Okay. I think this time I'll get some good pictures. Uh-oh. No problem. Let's take this. Just for understanding, I'm taking this. Mm-hmm. No. Okay. No. I'll better draw quickly. And so we have servers. Now the servers have got different models like 1240, 1280 and so on. If you see, this 1240 will have 4 port actually. 4 VNICs. Sorry, VIC, VIC, 4 VIC. 2 will be connected to the FEX here, that is IO module. FEX, we can also call it as FEX. Let's say FEX A or IO module A. The other 2 will be connected to the IO module B. Now, when these 2 are connected to this port channel here will be automatically created. That's what I want to say. The port channels we need not to configure. The port channels will be configured automatically. That is one story that I would like to emphasize here. So non-configurable port channels. Non-configurable port channels can be done. All right. One important thing, we'll finish and then we'll close. So do you have time?
Sir,
Yes.
yeah, of course. Sir, just question. So where is the role of FI? You just showed there are FACs. FACs means they will connect to.
Now this is connected to FI.
Also, this FACs is internal.
Yeah, FEX is nothing but IO module. From the beginning, I was saying IO module, right? It can be called as FEX also. This is not 2K FEX.
Okay. Sorry, I just thought.
Okay. I don't want to use the MUX word, multiplexer. What FEX does is fabric extender does the same multiplexing job. Correct, MUX job.
Yes.
So I use the word FEX. Our data center term.
Yes.
Now, one interesting thing you are going to enjoy now. What is that? Assume we got two fabric switches. Okay, I'll draw adjacent. Two fabric switches, and we got a chassis. Chassis has got 8 servers. 1, 2, 3, 4. Eight servers. And we also got the FEX or the IO module. 2 IO modules. And these all are connected. Somehow they are connected. As I told you, it will have 32 ports. They are connected. 1 or 2 port. It depends on what server you have, the number of connections established. Port channels are taken care. Likewise, this is internal, taken care. We don't need to do anything. But we will be adding profile to this VIC, virtual interface card, later, not now. That's too far. We are not into configuration now. Now,
Yes, sir, just a second. You are saying it is connecting, they are connecting internally to FEX.
yeah,
They are all-
internally. Yes.
Oh,
This is internal, inside the chassis. Not seen in our naked eye, but in our UCS manager, you can see this. On UCS manager, you can see all these VICs. You can configure.
wonderful.
Now, you got FI here, primary. Let me say primary, FI, subordinate. We don't call it as secondary, subordinate. Now, between this IO module, if I have only one connection, only one uplink, all 8 will go through. The traffic from all this 8 will go through FI primary. The FI primary will carry all the traffic. That is how it works. Now, if I have two uplinks, all odd will go using link number 1, all odd. Then I need to say which one is odd and which one is even. This is always blade 1. Blade 1. And you need to go to blade 2 here, right hand side. Blade 2, blade 3, blade 4, blade 5, blade 6, blade 7, blade 8. Now, if I have two uplinks, all odd, that is 1, 3, 5, 7 traffic will go through the red one, and 2, 4, 6, 8 blades will use the green one. That is how the traffic will go. Subordinate is the secondary one. Next, what if I have 4 links? Why you are not saying about 3? Why am I not talking about 3? There is no way you can have 3. You should not have. This is what permitted. 1, 3, 5. I'm sorry. You can have 1, 2, 4, 8, not 3. 1, 2, 1, 2, 4, 8. You can have 4 links or 8 links or 2 link or 1 link. You cannot have 3 link uplink. So if you have 4 link, how it is connected? If I have 4 link, blade 1 and blade 5 will go using the first link. See, if you see the diagram, it is very easy to understand. Blade 1 and blade 5 will go using link 1. And then blade 2, see, after 1 comes 2, blade 2, any guesswork? If 1 and 5 goes via first link, 2 and 6 will go via second link. Easy to remember. Via the second link. And then blade 3, see 1, 2, 3, 5, 6, 7. 3 and 7 will go via link third. And 4 and 8 will go via fourth link. That's all. This is how the mapping pinning will happen dynamically. This happens automatically.
Yes, sir. Dynamic. Okay. It is like good thing.
Yes. Another thing, if I have 8 links, okay, I'll write it here. I don't have space. I'll write it here. If I have 8 links, this is the order in which way it will go. First, the odd numbers will come. 1 will go with the first link, 3 will go with the second link, 5 will go with the third link, 7 will go with the fourth link. Again comes the even. 2,
So,
fifth
sir,
link.
I cannot see the screen, I think, on the left.
You are not able to see what I am writing? See, sir, here.
Yeah,
I'm
no, I
scribbling.
cannot see on the 5. I can see 572.
Oh, is it? Okay, I don't know this. Okay. This Windows machine is... Okay. Now, if I have 8 uplinks, all 8 will be used, but order is this. First link, first server will use. Second link, third server will use. Third link, fifth will use. Seventh, fourth link. Seventh. Second, fifth link. Fourth, sixth link. Sixth server will use seventh link, and eighth server will use eighth link. See, it is like this, sir. First goes and takes first, third goes and takes second, fifth goes and takes third, seventh goes and takes fourth, and then comes B2 fifth, B4 sixth, B6 seventh, B8 eighth. This is how the pinning happens dynamically. Now, there is another thing. What about the port channel? If I create a port channel, here the port channel is not dynamic. You need to create. If I create port channel, you know what it is. If I have port channel, which is not default, if I have port channel, then all will go through that port channel because it is considered as one link. If you have one link, what happens? All 8 server uses that one link. If you have bundle also, same story. All 8 servers will use that bundle. From where we configure port channel? From FI. So that is also one of the lab that we will be doing, I think even in exam. All right, so we are stopping here.